Protecting steel from corrosion is a chief use of high-performance coatings, and zinc-rich primers are widely known as one of the best. But what makes a zinc-rich coating better at preventing corrosion than other types of primers, and how does it compare to galvanizing? In this episode of Coatings Decoded, we'll discuss how zinc works, how it works within a coating, and the many benefits zinc-rich primers offer for easy application and long-term corrosion resistance. To the latest edition of Coatings Decoded, I am Mark Thomas, and today I'm joined by Randy Moore, Sales Director for Industry Affairs at Tnemec. Welcome, Randy.
Hey, thanks, Mark. Glad to be here.
Well, today's subject is zinc, and Randy, as I understand it, you have quite a career in zinc. Can you give us a little bit of information on your background?
Sure. Early in my career, back in the 80s, I worked for St. Joe Minerals Corporation. I was the market manager for zinc product line. We sold and furnished zinc metal into the hot dip galvanizers industry, as well as other applications. So I've had quite a bit of involvement with the Hot Dip Galvanizers Association and the Zinc Institute through the years. My educational background is a metallurgical engineer, so I've been heavily involved with corrosion theory. In fact, my master's, my emphasis was on corrosion theory. So I've been involved with zinc as a rust inhibitor for some time now.
Excellent. You sound like the right guy to have on this episode. So we are talking about coatings. Let's talk about the basic ways that coatings can protect carbon steel.
Yeah, sure. Coatings have primarily are three options. The first is just as a barrier. So if you can imagine a airtight monolithic barrier around a substrate, then you disrupt the corrosion cell such that the steel is protected and it can't corrode. So the first option for a coating is to behave as a barrier. And in fact, the other two options are barriers as well, but they bring other properties. In fact, the second one is a rust inhibitor barrier protection, which in the old days, there were a lot of older technologies that currently we don't see so much anymore with rust inhibitors, but they involved a lot of zinc chromates and those kind of things that are now long gone. But what's interesting is the very product Tnemec was founded on, our Tnemec 10 series, is a rust inhibitive structural steel primer, still the gold standard of the industry now 100 years later, works through the other rust inhibitive property of adjusting the alkalinity. If we can keep the steel in a slightly alkaline condition, then it can't corrode, it won't rust. So that's the second option. The third is a sacrificial coating. So that's a coating that would contain zinc particles, zinc dust, or zinc oxide that act as a sacrificial anode to keep the steel from corroding. It's anodic with respect to the steel, so the steel will be the cathode and it will not corrode. So those are your three options, either a barrier, a rust inhibitive coating, or a sacrificial coating. As I say, both the rust inhibitor and sacrificial coatings are barriers as well.
So with sacrificial coatings, and we're talking about zinc for the most part in this episode, what kind of coating varieties do you encounter with zinc-rich coatings?
Yeah, there's really two types. There's the inorganic zinc-rich coatings, which are in typically ethyl or silicate-based resin, and then the other is the organic, and the organics are typically epoxies, or a lot of them today are moisture cured urethanes. So those are your two options under sacrificial, either inorganic or organic zinc rich.
Okay, so let's start with kind of a basic understanding of how zinc actually works and how it protects carbon steel from corrosion.
Sure. When we say that it's sacrificial, what it is, as I said earlier, what's happening is the zinc particles are becoming the anode. So in a galvanic corrosion cell, you need a cathode, an anode, an electrolyte, and some means of electrical conductivity between the anode and the cathode. And so what the zinc does in the barrier coating, as a barrier coating with zinc in it, it will act as an anode with respect to the steel, and the steel becomes the cathode and then won't corrode, won't rust. So that's the sacrificial part. It becomes a sacrificial anode and therefore protects the steel.
Okay, so good understanding of how zinc works. Are there any situations you wouldn't want to put a zinc-rich coating?
Yeah, there's an interesting curve. The corrosion rate curve as a function of pH for zinc is really interesting. It's a U-shaped curve. And in fact, the ideal range for the use of zinc is with pH between a 5.5 and a 12. So strongly acidic or strongly alkaline, the corrosion rate escalates quickly, or it's almost exponential. It is exponential. And so you're going to have to avoid strongly alkaline or strongly acidic conditions. And I'm thinking there's places in wastewater plants, for example, certain heavy industries where we've got both acids and alkaline solutions that they use for cleaning. You'll need to avoid the use of zinc-rich primers in those situations. So you're looking for a pH somewhere between 5.5 and 12.
Okay. So where do you use zinc? What kind of structures would you see a zinc-rich coating applied to for corrosion benefit?
Yeah, that's a great question. There are a lot of applications. I mean, the bridges are probably the most common one, going back, starting in the late 40s, I believe, when we first started using the inorganic zinc-rich technology for bridges. But a lot of the marine environment still uses inorganic zincs. But exposed structural steel, you use the organics now typically. Water storage tanks, for example, both interiors and exteriors, but the water treatment plant, as well as, again, select areas in a wastewater plant, you'll be able to use zinc rich as well. Petrochemical, there's a great deal of zinc used in petrochemical. And in fact, pulp and paper, when we first started using the moisture cured urethane zinc rich primers, we did a great deal of work in pulp and paper mills with that new technology.
So the zinc rich coating is the primer. We've talked about how that protects the steel. Do you leave that untop coated? What kind of typical systems do you encounter with zinc rich as a primer?
Yeah, typically you for the inorganics, you could use it untop coated. There's a great deal of inorganic zincs out there that are not top coated. Part of the reason is they're difficult to top coat. But the organic zinc rich primers, we typically top coat with an epoxy intermediate and a urethane top coat, or a urethane intermediate and a fluoropolymer top coat. So yeah, there's a number of different combinations of epoxies and urethanes and fluoropolymers that we can use as top coats over the zinc rich primer.
And really, you were referencing exterior atmospheric kind of exposures, correct?
Correct.
And I know that there are manufacturers, Temic included, that have used organic zinc-rich primers in potable water immersion. Can you go into a little bit of detail of how that came to be and how that's performing?
Yeah. So yeah, Mark, zinc-rich primers are used in immersion service as well. We've had a great deal of experience since 1997 using a moisture-cured zinc-rich primer in water storage tank interiors. Now that system involves a zinc-rich primer and 2 coats of epoxy. And so we've had now 24 years experience with that technology and over 22,000 tanks in service. So we've got quite a long history and a lot of case histories with that combination of zinc and 2 coats epoxy in immersion service.
So we've talked about zinc-rich coatings, and I think a lot of people are they're familiar with galvanizing. We've all seen things that have been galvanized: guardrails, handrails, fences, lampposts, and et cetera, and structural steel as well. So if in terms of being a painting applicator, what would be the difference between utilizing and applying a zinc-rich coating, whether organic or inorganic, versus something that's galvanized that you need to paint?
Yeah, let's talk about the application properties. The inorganic zincs are a little difficult to apply. The surface preparation has to be just right. The application technique has to be perfect. They tend to be a little porous, so they can be difficult to top coat. Top coating, even top coating with itself, can be difficult. The organic zinc-rich primers are much easier to apply, and they have dry fall properties in many cases, and they'll have very short or relatively short recoat times or dry times for top coating, which is a real advantage for shop application. So, and then the top coating a galvanized, hot tip galvanized product can be very risky. Very common very common failure is trying to top coat a galvanized product with an epoxy, for example. The surface preparation requirements there are pretty rigid in that you have to make sure that the hot tip galvanized surface is clean. Often they'll passivate those surfaces with some chemical compound that'll need to be removed, and then brush blasting is required. And the disadvantage to that is one of the reasons you're using a hot tip often is to get just more free zinc to offer longer galvanic protection. But if we brush blast, now remove some of that free zinc and have shortened the galvanic protection time. So that's a real drawback to top coating the galvanized, is the need for surface preparation.
So it sounds like if you're wanting to use some kind of zinc-rich corrosion protection system for carbon steel, there are fewer variables to consider if you're going with an organic moisture-cured urethane zinc-rich versus even an inorganic and certainly a galvanized.
Yeah, for sure. And I think that's why we're seeing such a prominence for the moisture-cured urethane zinc-rich primers in the industry today, in a lot of different industries, really because of that ease of application from a contractor standpoint.
All right. Well, just kind of finishing up here, Randy, appreciate your time. Is there anything else as we wrap up this session that you'd like to share?
Well, yeah, I might say that again, with our track record for zinc-rich primer in immersion service on water storage tanks. As I said, we have 24 years experience now. What we found is that when that technology first came out, the NACE Brevoort report was expecting about a 50% increase in service life. What we now see some 24 years later, if a two-coat epoxy was a 15-year average, let's say, service life, we're now seeing 24 years with zinc and two coats of epoxy. And we've looked at some recently, some case histories with tanks we've gone into that are 24 years old. And we got a little touch up. They're going to require some maintenance, but we're projecting another 8 to 10 years. So now we've got a 30+ year service life possibility with zinc and two coats of epoxy. The key takeaway there is we've doubled the service life. What does that mean? Well, by doubling the service life from 15 to 30, let's say, years, we've lowered the life cycle cost significantly. And so with the lowest life cycle cost, we now have the most sustainable solution, which is really the objective of any asset management program, is to optimize the life cycle cost and obtain a sustainable solution. And that's exactly what happens when we started to use and with the advent of zinc-rich primers. So that's a key takeaway. What it's done for our industry is significant.
That sounds great, Randy. Lots of good information in this session. We really appreciate your time and thanks for joining us.
Yeah, my pleasure.
Zinc-rich coatings offer excellent corrosion resistance, easy application, and can be top coated with a variety of high-performance intermediate and finish coats. These attributes make them an excellent alternative to other primers and traditional galvanizing when long-term protection of steel is required.